we're in good shape. We're just going to make a modification to what we've done. So, so we already have this caregiving state chart, but we're going to actually need to add an additional state to it. I should have noted this already. Okay. Okay. Great. So this is what we should do. We have a not seeking care state. We're going to take this thing that says seeking care, and it's going to be instead called under care. Okay. Yeah. So we're going to change its name to be under care. Okay. Under care. Yeah. Okay. Yeah. This is the least bad way to do it. I should have been more careful. Fine. That's under care. And ladies and gentlemen, I'd like you to add a third state between the two that's called in transit to care. Okay? So we're going to modify this with something called in transit to care. In transit to care. There we go. Okay. My apologies.
So I see, Nate, that you're changing the transitions around. Is that important, or is that just temporary? Ah, I see. Okay.
Yeah. So we're fixing up this with an additional transition here. Okay. This new state is in transit to care, and then we have under care, and then it's going to return to not seeking care. Okay, that's great. Ladies and gentlemen, I'd like you to go to the entry point to not seeking care here. The entry point to this should now include the code jump this.jump to, or you can just say jump to home.getX, home.getY. Get Y. Okay? Great. Okay. Terrific. Terrific. Okay. And now we're going to introduce a variable as well that's called nearest clinic. Okay? Okay. I'm sorry?
The variable will be under main.
No, the variable will be under person. Okay, the variable, there'll be a variable called, oh gosh, I just did something terrible. Okay, okay, there'll be a variable we introduced to person called nearest clinic. Okay, and guess what type that will be? It'll be of type what? Clinic is right. Okay, it'll be of type clinic. Okay, folks? So a new variable of type clinic will be included. And the variable is called nearest clinic. Okay? Okay? And I'd like you to do this. Okay? So where's the variable value going to come from? In this not seeking care, I'd like you to say nearest clinic equals, and we're going to find the nearest clinic, okay? We're going to say get nearest agent and we're going to say main.clinics. Okay? So let me go put that up on the big screen. I'm going to have to go build a big screen here. Okay. Okay. Great. Okay. So, folks, this is the code there that we're inserting into that initial state. Okay, actually, I'm sorry, this should go into the entry point. It's actually not in this state. It's actually this entry point here. Sorry. Again, I should have been more careful. It's the entry point. Okay? So this is where this goes. Jump to the home, and then it says set the nearest clinic here. Yes? So, okay, so you have a what? Yeah, yeah. Okay, that's because, here, you have to say nearest clinic. You click on nearest clinic. That's because it's a double, it needs to be a clinic. Remember that nearest clinic needs to be a clinic. Okay? How long, what? You mean for the timing of that transition? Yeah, it's just leave it as the default. No, here. Let me verify this. Okay. So that's actually based on the agent arrival, okay? So this transition, okay, I'm wondering if I should wait a little bit. For those following along, this transition from in-transit to care to under-care, this is going to be a new type of transition. This will be called arrival, and it's going to be a agent arrival transition. In other words, when we arrive at the destination, that's when we're going to make that transition. And the final thing that we're going to do here right now is for this transition here, this earlier transition, we're going to, so all we did for this transition is we set it to be based on agent arrival. This transition here, we're going to set so that there's an action associated with it, which is this dot move to nearest clinic dot get X, nearest clinic dot get Y. Okay? So for this transition here, not seeking care to in-transit to care, and I'm going to change its rate to be 0.05. Okay? Okay. 0.05, and it is under its action doing, and I should really be consistent about using this. I think I'm going to remove it from consistently here. There we are. Yeah. Yeah. Okay, this is for the entry transition, and this is for the transition to enter transit to care. That's that one. So what's going on here is, in the entry to the whole state chart, we're going to our home location. We're going to be based on our home. And we're determining what our nearest clinic is. And then, when it comes time for us to go seek care, we move to the nearest clinic. We're going to move to the nearest clinic. And this is the X location, the nearest clinic, and the Y location, the nearest clinic. Okay? Okay. Yeah. Oh, you know, we can even simplify this. This is great. Instead of making it move to this thing, make it instead move to nearest clinic. That's actually cleaner. That's good. And we could actually make it, so this is an AnyLogic 7 thing, I think. And we could actually make it jump to home rather than jump to home.x, get x. That should be jump to home. We can do that. You don't have to, but I prefer that. I think it's much nicer this way. Jump to and jump to. Nope, you can't do that with jump to. You can only do it with move to. Too bad. There we are. Only with the move to.
Do jump to and move to operate differently?
Yes.
And jump to is instant.
It's instantaneously. Move to sets you going to there. Okay. Okay. That's good. And now, yes.
Why do you need to identify nearest clinic at the start of the state chart and then move to that? Can you just jump to and then add the nearest clinic?
Yeah, it's just that you could do that. Yeah, you could do that. I guess I thought we'd do it once because the homes aren't moving around and et cetera, but you could in fact do it, and that would be a little bit more per Roberto's interest in resilience. If a clinic closed, then it would still work. So that's a nice idea. I like that. And if you'd like to try that, that would be a nice variant of this. Instead of saying you have to have a variable and predetermine it, instead you could say move to, you know, get nearest agent. That would actually be very elegant. I prefer that. But this is just, yeah, I mean, probably I'll change it to see that. That's fine. Yeah. Okay. Good. Yeah. Yeah, that looks right. That's correct. And you can abbreviate it by just saying move to nearest. Yeah, this, well, in other words, you don't need to get X, get Y. In other words, you can just abbreviate this, I discovered, with this.
Because when you were just
Yeah? That is correct. This one we haven't done, no, this one is based on capital, it's based on here, capital C-U-R-E. You know, without that. If you find, I could have had a define that just a message. So that would be fine. Yep. Okay, who needs help here? Who needs help? Okay. Okay. So, folks, I'd like you to run this now. So build it, and what happens? Okay. Like you to run it. What do you see? Okay, they're moving. Okay, in mine, they're moving awfully quick. In yours, are they moving slowly?
No.
Same thing. Okay, that's an interesting thing. We may have to set the velocity of the person. Pardon me, well, the elves work.
The reason why that, so default
Speed.
scale is 1 meter is 10 pixels.
I see.
And initial speed is 10 meters per second.
Yes, okay.
So given we're working with
That's
the
pretty
timescale,
fast.
Days.
What's that?
If we set the time scale to be days. Before,
Indeed,
so
indeed, yeah. I see. So, one option will be to change this scale. Yes. So that's. So we could change that in a couple of ways. Okay, one thing we might want to do is set their velocity to be slower. Okay, let's check this out. So what I'm going to do is I'm going to actually slow this down a lot. Okay.
you're going to be waiting a while.
Long time for somebody to get.
Indeed, this is the issue, yeah. Okay, so maybe the simplest thing to do is to set the velocity to be very low. Set velocity to be 0.01 or something like that. And now they'll go much more slowly. Okay, they're moving. Okay. Now that looked kind of zombie-like to me, but okay. Maybe that's a bit too slow. Okay, that's almost geologic. Okay, let's set the velocity again. Let's set the velocity in the entry point to be 1.
It might be a good idea to do that through the interface rather than coding it.
Okay, that's not a bad idea. Yeah. Okay. Fine. Okay. This is something that changed between AnyLogic 6 and 7, and hence I'm being troubled by it. Okay, fine. So under person, yeah. The velocity.
Yeah, person movement. And
Yeah.
initial speed.
Exactly. Okay. There we go. Sure. We could set this, and this is in meters per second. Okay. Okay, we'll make it a much smaller speed, or pretend they're walking at a stately pace, particularly when seeking care. Okay, they're still moving way too fast though. Because it's a day. It's a day at a time. Yeah. Okay, well, maybe we should change the model time units then to hours. Okay.
Will transmission rates and stuff change?
Not, well, I mean, they've already been specified, so they won't automatically change. But, so if we do it as hours, those will already be specified correctly. In terms of days. But the problem is it will be a long time between when people seek care. And so observing an individual instance of care, oh gosh.
The movement is still quite fast.
Yes, the movement is still very fast. Okay, sorry, this is an AnyLogic 6 example which I've tried to adapt, and it's going to take a little bit of thinking on my part. How best to deal with this. So I don't want to change the underlying time constants for the.
If we set an initial speed of 0.0001 meters per second,
Yes.
and we remove that rotate animation, it looks pretty good. 0.0001.
Okay, but I've changed the time unit to hours. Yeah. So you know, I don't like putting in these magic numbers, but yeah, it's still really. You can now see them traveling, which is better. There's some evidence of them traveling, but that's still not good. Okay. Great. Okay. Yeah. Okay. This is better. This is better. Now, if we slow it down, you can actually see the decent movement. Okay, folks. Sorry for the delay. I just needed to rejig the times here. This is an AnyLogic 6 example, and I didn't have the times aligned with the spatial scales. Okay, so I'd like you to do two things. The first thing I'd like you to do is go to the model as a whole, and I'd like you to set it to be model time units in hours. Okay. Now that's not going to change any of the existing time units you've specified in the model time constants for transitions, but that's fine. That's exactly the point. I want it to be based on hours, which will be a natural time unit in which to describe care processes, first of all. And second of all, that's one thing I'd like you to do. So go set it to be hours as the time unit for the whole model. That's the first thing, okay? So where do you do that? You do that the model as a whole, and you specify model time unit hour. Are people okay with that? Okay. The second thing I'd like you to do is to go to person, and I'd like you to go set the initial speed for a person down in the movement area of person to 0.01 and choose meters per second.
If we remove that rotate animation, it actually looks much better.
It does look better with that. Okay, so I like that, Sunkalp, thanks. Remove the rotate animation towards movement. Okay. Okay. Okay, so I'm just annotating my notes here to correct this in the future. So who needs TA help right now? TA? Roberto? Okay. Great. Okay, so folks, sorry for that. Okay. So, what should you see now? It should be something like this. People are moving for care from their homes, right? What's that? Oh, I thought it was kind of nice to see him. Okay. It's a long commute. Okay. Okay, so folks, we have this movement going on. Who needs TA help to see that? Okay, there we go. Great. Okay, so with that, we're going to be done with this state chart, but we're going to add one more state chart. This is the one that was based on the cured message? Sorry? That's one where you haven't dealt with yet. Okay. Okay. So, okay, so folks, what I'd like to do now is, okay, I'm sorry. This transition here, back from undercare to not seeking care, will be based on a message, but it will be based on departed healthcare facility instead of cured. Okay. 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 Yeah, I want this to be departed healthcare facility rather than this this other one. This is due to a lapse in my clarity of my notes. Okay. Okay. So folks, this state chart is associated with care seeking. We're going to add one more state chart associated with their underlying health state. Okay, and this is the one I had started earlier, but had renamed. Okay, so this is going to be health state chart, and there's going to be two states in here. One is healthy and one is ill. Okay, healthy and ill. And here, I would like the transition from healthy to ill to be based on a rate transition of 0.01. So this would be becoming ill. 0.01 is the rate, and that's per day. Okay? It's a rate per day. Remember, the units of the model now are hours, but this rate is a per day rate. And then going from ill to healthy, this will be based on a message, and this message is cured. Okay? So one state chart is going to be based on, this state chart is going to be based on cured, this state chart is going to be based on departed healthcare facility. This transition here, which is becoming ill, is associated with a rate of 0.01 per day. So we've added this new state chart. Healthy and ill are the two states. This transition from healthy to ill is based on a rate of 0.01, and from ill to healthy is based on this message transition based on a particular message cured. So that's based on the particular message cured. This other one, by contrast, earlier was based on the particular message departed healthcare facility. Okay? Okay. So that's good. And the final thing is, I had set this color. The color actually set to green and red should be for healthy and ill. So we need to copy those guys over. I'd used them for the other state chart, and that's incorrect. There. Okay. So the first state chart we created should have no reference to color in it, but this state chart does. We set them to green if they're healthy, red if they're not. The movement will be indicated for the other state chart, and that will be enough. We don't need a color. Okay. Great. Right. Okay. 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 And then finally, this transition here, transitioning based on departed healthcare facility. For this, we should do move to home. Move to home. Like that. Okay, so this transition, to go over these transitions again, this transition from healthy to ill has a rate of 0.01 per day. This is very important, it's per day. This transition back is a message transition based on a particular message cured. This transition here for not seeking care to in seeking care is going off with a rate of 0.5 per day. And this transition from in transit to care is based on arrival. And this transition from under care to not seeking care is based on the message cured, and we move them to their home. Okay? Okay. So we're most of the way done with this model, but we have the hybrid part still to go. So. Oops.
The one right here, it says ill.
Okay, cured. Messages are, yes, should be cured. So, oh, I see, I probably entered it the wrong. Yeah, of course. Yeah, okay. Good. Okay. Oh, so,
That could have been close. There are a lot of cables here.
okay, so there's two state charts here. Yeah, I'll be with you in just a sec. There's two state charts. One is governing health, and there, these transitions are based on the underlying health state, and this is based on an actual successful cure. On the other hand, this transition is based on care seeking. With a certain chance per unit time, you move to the healthcare facility. When you arrive, you transition to an undercare state, and you depart when you go back to your home via a departed healthcare facility. Okay, are people okay with this? Who needs help? These two? Okay, this one here is with a rate of 0.01 per day. And there's nothing that occurs, no action with it. This one here is with a message. It's contingent upon a particular message, and the message is cured, C-U-R-E-D. There's no action associated with it. Okay? Who else needs help? Yeah. Yeah. Oh yeah, it's just one of these transitions is not correctly blanked on both sides. Yeah. Okay, this is green on both sides. This is green on both sides. This is green. This is green. Oh, it's because this thing is not. There you go. Okay. And then departed healthcare facility, it doesn't understand. Maybe it's misspelled. Departed. Depart. No, it doesn't seem to know it. So let's go to option types. Departed. Oh, it's just he misspelled this here. Yeah. Messages departed health with a capital C. Okay, try that.
Yeah, nearest clinic is basically reference to the entire clinic. So if you imagine
Say this again?
the entire clinic.
Well, that's because they don't, as soon as they're ill, they don't necessarily go to the clinic. It takes an average of about 20 days. So could you speed it up? Yeah, some of them are going to the clinic.
Imagine you've got a bag,
Thing.
and then you've got bags inside the bag, and then like there's like still more bags inside the
There's
stage.
something that
So
okay.
this is
So yeah.
the nearest clinic itself is much better.
Can you slow it down?
Really strange.
Yeah, so everything that the clinic
Yeah, keep going.
is stored in
Because they're not leaving the clinic, so you don't really see it. See, they're traveling around. So I think they're actually going, it's just that it's at a rate you can't immediately see it. It'll be more obvious when we have the care process in place. Okay, so how many people are ready to go on to the care process? Okay, Robin. Yeah, there's a bit of logic there that we're going to have to put in now that we've added this state chart. In fact, I should probably do that right now. So, folks, this transition here it's with a certain rate, but right now it's independent of their illness. So we need a guard here that basically indicates whether it only allows them to go that transition if they are ill, okay? Okay, so what I'd like to do here is I'd like to have something that says they're ill. How do we determine if they're ill in this if we look at this person, how do we say if they're ill? Yeah, the health state chart. Okay, so basically this will be health state chart dot is state active, and what's the state? Ill. Now, if we wanted to write this in a way that will work externally as well, if we ever need it, it will be person.ill, but either way, you could just say ill for this context since we're already inside person. Okay, so this will limit the care seeking to those who are ill. It will only allow it if someone is ill for them to go seek care, okay?
So that expression is true.
If this is true, then they're allowed to go at this rate. No, it doesn't, because this is computing a value. It's not telling it do something. It's not saying make this person twice as large or infect them. It's just getting a value. This is returning true or false.
Would your advice on a condition, triggered by condition?
Yes, but we don't want it to go immediately when they have that condition. True. Okay? Okay, it looks like some of you are having trouble seeing the person's move because it's just too fast. What I'm going to do is, at the cost of asking you to do another change, why don't you go change the initial speed for person to make it 10 times slower. Make it 0.001. I think this is what Sankalp was after. So if you're having trouble seeing the move and you want to see the move, go to person, scroll down to movement, make it 0.001 meters per second. Now they're kind of moving like a snail. Okay, and now you should see something like this. They're going to become ill. Why don't they immediately move when they're ill? Because what? Well, okay, let's go through this. It's important to understand this logic before we go on to the final stage. So suppose someone is healthy. Are they going to go seek care with this model? Why not? At a mechanistic level, what's preventing it? The guard, the so-called guard, which means that they're only allowed to go down this transition if this thing is true, if they're ill, okay? So they're not going to be seeking care while they're ill. Now, what happens when they are ill? So they transition to an ill state. Are they immediately going to go in for care? There's a rate associated with it. So they're only a candidate for going down this path when they're ill, but it's not going to immediately go down the path. It'll be with a certain rate. And how long on average will it take them to go down there? If you look at that rate, what will it be? Sorry, 20 days, right? 20 days on average. It'll take them to go into, to enter that transition. So, ladies and gentlemen, if you run this, you should see something like this. you should see people turning ill. They're not yet in transit. And I'm going to turn down the speed here. Okay, so this is going hour by hour here. So we've got a couple people who have been ill, and now they're moving into the facility. Now this again was with the speed of 0.001 meters per second. So they're going very, very slowly, but you can see them presenting for care at this facility. They're moving to the various facilities. Now, right now, are they leaving that facility? No. It's kind of like a warehouse right now. So we need to complete the circuit. We need to complete this. Okay, I need an indication from subs. I think it's time for tea. Okay. And how long do you want it to be until we're back? 10 minutes? Okay, let's do 10 minutes then. Great, thanks. And I'm glad to help people get it working if you're having trouble here.